in SO2 case, the simplest example we can think of, it's two-dimensional space, like this plane. So let's see how the group acts. SO2 group acting on state space, which is just a plane. I can use coordinates x and 1 and x and 2 to specify any point in the plane. And what I already know, because I have intuition about this, I know that if I take a point, the action of the group will be just to run it around on a circle. So if my system is SO2 symmetric, it means one of the dimensions that's easily understood in polar coordinates is the radius. So if I have a point xt, two-dimensional point at some time, I can write it as a radius at time t and the angle at time t. And everybody of the same radius is physically equivalent. I can just take one of these points to describe the dynamics. Now what's t? What's t? In this two-dimensional plane, t is an antisymmetric matrix. And there's only one antisymmetric matrix. So t is just this matrix. I will define something called group tangent. So what happens if you move infinitesimally at this point in the group direction, in group transformation? I'll use little letter t, fat or something for that. That depends on which point I am. And it happens to be just t times wherever I am. So if I'm further away, the group tangent is bigger. And if I write this out in components, it just interchanges. It takes the second component, puts it here. First one puts it there. And if you remember your high school geometry, that's actually rotation by 90 degrees. So it turns out a group tangent is always orthogonal to where you are. So it has a very nice, degenerate has a very nice interpretation. It says I'm not allowed to move outside or inside because that's a different field. It has a different distance that belongs to some other orbit. For example, if this was a harmonic oscillator, they would have different actions. If this was mechanics and this was Q and P, and you move on a circle, then different states of a harmonic oscillator or motions on a circle are specified by the radius, which is the angular momentum and the thing. The group tangent is just normal. So the meaning of this antisymmetry is that I can only move in direction that doesn't change length, which is always a direction normal to wherever I am.